Welcome to part 1 on vectors in 2 dimensions with applications. We're going to start by looking at horizontal and vertical components of a vector. If we let the vector v be a vector with magnitude, absolute value of v, and direction theta, this is calculated by the smallest positive angle in standard position formed by the positive x-axis and v. And you can see that in the diagram below. Then the vector v in component form is AB, and this is also equal to AI vector plus BJ vector, or AI plus BJ, where A is the magnitude of V times cosine of theta, and B is the magnitude of V times sine of theta. Thus, we can express the vector V as the vector v equals the magnitude of v times cosine of theta times the I vector, unit vector in the x direction, plus the magnitude of v times sine of theta times the j vector, unit vector in the y direction. And this can be shown in the image below, where we have the magnitude times cosine theta. Now, if we were to define what this means, the magnitudes are in the absolute value, and the cosine and the sine of theta are the direction. Let's take a look at the first example. A vector has length 5 and direction 2 pi over 3. Find the horizontal and vertical components and write the vector in terms of I and j. Let's first sketch the graph of the xy axis. And then let's draw the angle. We'll call this 2 pi over 3. And it has length 5. If we find the horizontal and vertical components and write the vector in terms of I and j, we first need to think about how we could represent the height and the horizontal displacement as well. The height is going to be sine of theta, and the horizontal shift will be cosine of theta. Since 2 pi over 3 is in the second quadrant for an angle theta, we will have to keep track of that as well. If I know the magnitude of the vector is equal to 5, and I know that sine of theta is going to equal sine of 2 pi over 3, and cosine of theta will be cosine of 2 pi over 3. Then from there, I can write the vector in terms of the I, unit vector I, and unit vector j. First, I'm going to list the I direction, or x direction. Then I'll list the y direction, or the j vector. And I know that it's going to be a sum. I know that cosine of 2 pi over 3 is equal to negative 1/2. And I know that the magnitude of v is 5. I'm going to add that to 5, the magnitude, times sine of 2 pi over 3, which will be root 3 over 2. So once again, I'm using the formula magnitude of v times cosine of theta times the I vector, unit vector I, and plus the magnitude of the vector v times sine of theta times the unit vector in the y direction, or j. So we can say that the vector v is equal to 5 times negative 1/2 I plus 5 times root 3 over 2j. Let's take a look at the next example. We need to find the direction of the vector u if it equals negative I plus root 3j. Let's take the components of the vector u, which we can see are negative 1 and root 3. This will allow me to keep track of the steps in the x direction and the y direction. From here, I'll note that this is like my x value, or change in x, and the second value in the component vector is the change in y. And that will give me an interesting bit of information. I know that tangent of theta is equal to y over x, so I'll go ahead and write this as root 3 over negative 1. That gives me theta is equal to the tan inverse of negative root 3. Therefore, theta is equal to 2 pi over 3.